Yes.
Mark Wyvion, is he in here?
Isis.
Are y'all done? Y'all ready to move to the second question? All right. Malika, go ahead and read that question for us.
The student records the following data after combining two substances. Which conclusion is best supported by the data?
Alright, and what did you need to do to answer this question?
Read the table.
Okay. And what did you select and why?
B, because B, a chemical reaction occurred because a gas was produced. Substance A and substance B both didn't have a gas, but after mixing them, the color changed and a gas was formed.
Okay. So how did you know it was a chemical reaction?
Because, like, a gas is formed and also because you can, like, put it back into a solution of thing.
Okay, so was this a physical or chemical?
Chemical.
Y'all agree? Alright. Alright. Jeremiah?
I chose B. A student mixes iron fillings and sulfur powder. Before heating, both substances can still be seen and separated with a magnet. After heating, the new substance cannot be separated and has different properties. Which claim is best supported by the statements? I chose B.
B, a chemical reaction occurred because a new substance with different properties formed. Okay, why did you do this?
Because the last sentence of the question says that it has different properties and the new substance cannot be separated.
Alright, quick question. Mixture, what's the mixture? What is a mixture?
Physical change.
I think it's a physical change. In your own words, what's the definition of a mixture? Jordan.
A mixture is something that you can separate and see all the things. It's
Okay.
a mixture.
Okay. What's your definition of a mixture?
Two of the same molecules mixed together.
You said two of the same molecules mixed with different molecules?
A mixture is two of those substances that are mixed together that can be separated by physical means.
How many types of mixtures have we discussed?
Two.
What's one of the types? Alright. Heterogeneous. And what's the other one, Ash? Homogeneous. Y'all remember the two types? Y'all remember what they are?
Yes.
We're gonna see. Alright, so let's review over elements, compounds, and mixture. That is our goal for today. We're gonna be talking about standard 7.PS 1.2. Okay. And if you forgot or need to jot down anything, that will be perfectly fine with me, okay? Not gonna stop you, because this is the review that you need. There's some of you probably may have forgotten that it's table too. And I wanna make sure everybody gets it. Alright, so before we get started, let me show you the standards that we are on. So this is the standard we're gonna be doing, working with today. It includes a lot, but collect and analyze data about the physical properties of components of a mixture to use evidence that the identities of the components change during a chemical reaction. And, we're just talking about one part of this standard really today.
A compound and mixture, and see how they relate. Welcome to Numismatic Science.
An element is a pure substance. In other words, an element cannot be broken down into a simpler substance.
So what's an element? First is a pure substance. What does a pure substance mean? Can be broken down. What's the meaning of pure? Something is purebred. What does that mean?
Like, it's original.
Original? It's original. It's not mixed with anything. Okay. So we know an element is a pure substance. else do we know? Well, like, what else? It's a pure substance, and what else we got to do? Did you listen to what they just said? Can't be broken down. Okay.
Physical or chemical means. An element is made up of only one type of atom. An atom consists of a proton, neutron, and an electron.
Alright, so only what? One type of atom. And we know atoms consist of protons, neutrons, and what else? Electrons. What type of charge does the proton have? Positive. What about neutrons? Neutral or no charge. And electrons. Negative. Alright. Keep going.
Some common examples of elements would be carbon, oxygen, or iron.
What do you know? This is only one type of wood. Only one type of atom. Alright, so if you see this by itself, carbon by itself, oxygen by itself, iron, which stands for Fe by itself, we know that it's only one type of atom, and that is what? Element. Any questions? Right out. What would that look like if I was to draw a picture? How could I represent that if I was to draw a picture? All of them might be the same color, the same shape. So I could draw what? Just say if I want to draw some triangles. Are those all elements? Yes. Because it's only what? One type of atom. Can't break it down into anything simpler. And we know it's a pure substance because it's not mixed with anything, is it? So they're all triangles. Got it? I don't do anything wrong. I don't do
The elements are arranged on the periodic table based on their number of protons. For example, sodium has 11 protons. Potassium has 19. The number of protons of an element always stays the same. Each element also has its own unique set of properties. A compound is a pure substance of two or more elements chemically combined.
What's a compound? Hold on, start off with the first part. It's a what? It's a pure substance as well. That's very important because it's also a pure substance. And then what else do we know? Two or more what? Two or more elements that are what? Chemically combined. So it's a pure substance and two or more elements that are chemically combined. So why wouldn't I say two or more substances? Or you could say two or more atoms. I wouldn't say substances because when we talk about substances, we more so gonna think about a mixture. And that's how you get your brain confused between a mixture and a compound when they're asking about the definition. Okay. Alright, so what would that look like? Give me an example of a compound. Alright, so water. H2O, right? You got your oxygen and you got your water. Chemically combined.
Elements combine during a chemical change. A particle of a compound is called a molecule. When the elements combine chemically, a new substance is created. This compound has different properties than the elements that make it up. Hydrogen and oxygen are gases, but they combine to make liquid water. Here are some items that combine to make compounds. Table salt is sodium and chlorine. Glucose, a type of sugar, is made of carbon, hydrogen, and oxygen. When elements create a compound, they always join in a specific ratio. The ratio of water is 2 hydrogen to 1 oxygen. If a compound has a different ratio of hydrogen to oxygen, then it is not water. Glucose, a type of sugar, has a ratio of 6 carbon to 12 hydrogen to 6 oxygen. Glucose will always have the same ratio. Compounds are all around you, in the food you eat, your school supplies, and even yourself.
When two or more substances are mixed together, but do not bond chemically, they form a mixture.
So what's a mixture? Two or more substances
Mixed together.
But they don't bond chemically.
okay, mixed together. Do not bond chemically. Now do y'all see the difference between compound and mixture? This one are different. This one is chemically combined. This one is not. Two or more substances mixed together. They don't bond chemically. That is a mixture. Two or more substances that are mixed together and they do not bond chemically.
A mixture can be separated by physical means. Air is a mixture of gases. Sand is a mixture of shells, rock, and even plastic.
What would be an example of a mixture?
Salad.
Salad, trail mix, okay, fruit, chemical, marshmallow. I think y'all just hungry. Alright, here
Two
we go.
major types of mixture. A heterogeneous mixture is one in which you can visually see the different parts of
Alright, here we go. Heterogeneous, you can do what? You can see. Let's draw our eyes. We can see. We can see the different parts. So, give me an example of a heterogeneous mixture. Water and sand. Give me one more. Oil and water. Water. Alright.
the mixture. Sand is an example. Salad would be another example of a heterogeneous mixture. A homogeneous mixture, also sometimes called a solution, is a mixture in which the composition is uniform throughout the mixture.
Alright, homogeneous mixture, what happens there?
Same throughout.
It's the same or uniform throughout. Can we see all the different parts? No. Let's draw the as. Let's say no. An example of that, we also call this a what? Solution. So give me an example of homogeneous. Kool-Aid. Anything else? Isaiah. Alright, sugar and water. Yep, they do. All of that.
The ocean?
Hmm. Ocean. So it's water. Salt water.
Salt water.
Lemonade. Alright, let's keep going.
Salt water is only used because the dissolved salt is evenly distributed throughout. Alloys, which are made up of two or more metals, is another example. This would include brass and bronze. Liquid soap is another example of a heterogeneous solution. There are many ways that you can separate a solution. For example, you can use filtration, distillation, which involves heating the mixture to various boiling points, and magnetism, which involves passing a magnet over the mixture and removing magnetic points. Thanks for watching, and remember, kindness multiplies kindness. Time to someone.
Alright. Give you like 2-3 minutes. With your partner, go ahead and discuss element, compound, and mixture. What's the difference?
The difference between the element is that it's only one type of atom and it can't be other. Y'all agree? And the difference between a compound is pure substances containing more elements in their chemically combined. Y'all agree? Okay. And mixture, two or more substances that are mixed together, but they're not chemically combined. Y'all agree? That could work too because it's cinnamon no, that's dough. It's dough. Bread is wheat. What are you talking about? Bread is made from wheat. Dough. Dough like flour. Yeah. So bread and dough are not the same thing. So. Compounds in their substance.
Now that you have discussed that with your group, alright, I'm gonna give you some time, and I might tell you, I'm going to tell you to build a model with your group very quickly, representing elements, compounds, and mixtures. So give me just a moment. Okay. Emery, tell us your understanding of an element.
It's a pure substance and it can't be broken down.
Okay, what does a pure substance mean to you?
It's like one thing and it,
Huh?
it's just one thing. That's all.
Is it just one thing? Okay. Charlie, what's your understanding of a pure substance?
Of a pure substance?
Yes, pure substance.
Oh, pure substance.
Mhm.
A pure substance is when there's no other things in it. It might be something like pure oxygen, pure hydrogen, or pure gold.
Okay. And what is a compound to you, Michaela? How would you describe a compound? Two things. Use your vocabulary. Two substances for compound. Okay. Okay. And give me an example of a compound, Gabrielle.
Pure substances with two elements that are chemically bonded.
Give me an example.
Oh, I'll say water.
You say water?
I'll say salt.
Water is a compound? Yes, so. Maybe so. What's the formula for water? H2O. So, Gabrielle, what does H2O consist of?
Hydrogen and oxygen.
If your name Gabriella, you shouldn't have your math oxygen. It consists of what now?
Hydrogen and oxygen.
Hydrogen and oxygen. So how many elements are you saying? How many elements? Two. Alright, so we know there can't be a what? If you just said two elements, you know it can't be a what? Can it be an element? Can water be an element? Why not? One atom. You have more than one, right? So that will result into a compound. Alright, so what I'm going to ask you to do is represent an element, but we're going to take this up here first so you'll see what I'm talking about, okay?
What kind of stick does?
I'll bring us some. Alright. Y'all ready? Element, compound, or mixture. Alright. Trail mix. Y'all discuss the rules. 30 seconds. Tell me whether the element, compound, or mixture. If it's a mixture, you gotta tell me what type.
It's a
Discuss with your group.
It's a heterogeneous mixture. Heterogeneous mixture. Agree?
Alright. Now,
It's a heterogeneous mixture because you can see the different properties in
okay. How would we separate trail mix? If we had to separate it, what would be the easiest method to separate it by? Tanisi? By hand. Good job. Easy. Alright, talk about neon. Quickly. Neon is next. Talk about neon.
The light.
Element, compound, or mixture. Neon.
The light, the color, like.
Neon.
What you mean neon?
Neon.
Neon what?
The color. Neon stands for E and E. Talk about neon.
The light? I'm confused. The sign? Like, the light the sun is producing? Like,
I'm just telling you what it stands for. Capital E and E. If you seen it on the assessment, capital E and lowercase e. Element, compound, or mixture.
She said uppercase N and lowercase n.
uppercase N and lowercase n.
Neon stands for uppercase N and lowercase n. That's what she said. So it's a compound.
It's an element.
How is it an element?
Lowercase e. Uppercase F and lowercase e. It's an element.
Alright, here we go. Let's get RJ. Neon, element, compound, or mixture, and why?
Element.
Element, why?
Because it's not chemically combined with anything.
Right, it's by itself, right? Neon, I said capital N, lowercase what? Capital N, lowercase e. It's only one type of what? Atom.
I just heard E and
Alright, capital N, lowercase e. One type of atom. Alright, let's clear up a misconception. Some elements have a capital letter and a lowercase letter. Okay? That is still going to be only an element. Now, when you see 2 capital letters, that means that is going to end up being a what? Okay. Alright, here we go. Gold. Element, compound, or a mixture.
Bruh, y'all sure?
Yes, it's on the.
Okay, look. It's a y'all agree? It's an element? Y'all agree it's an element?
No, it's still occurred.
Alright, here we go.
Okay, Jenny.
Damien. Gold. Would it be an element, compound, or mixture? Element, why? It's a pure substance. Good job. Alright. I ain't gonna give you all the hints. The next one is table salt. Table salt.
Oh, it's obviously a compound. Yeah. It's a good compound. You don't think NaCl, right?
Table salt.
NaCl. Exactly. It's NaCl. This is salt.
Alright, here we go. Kimaya. What do you think? Element, compound, or mixture? Compound, why?
I forgot what it is, but it's sodium.
Chlorine.
Alright, what is the formula for table salt, Ari?
Isn't it sodium and chlorophyll or something?
Yeah,
What's the chemical formula, RJ? NaCl. NaCl.
I told y'all.
So that represents a compound. Good job. Alright, here's the next one. Y'all ready?
No.
Oh wow. It's so hard.
I need your I need your
No, I want to keep it. Alright, take it all. Kelvin, that's what my share. You won't even give me a
Alright. Let's see. Okay, Brayden. Salad.
It's a heterozygous mixture because you
Hold on.
heterozygous.
heterogeneous.
Heterogeneous mixture. Heterozygous from different.
It's a heterogeneous mixture because you can see everything on the salad: carrots, onions, lettuce.
Alright, good job. Alright, the next one is O2. O2. Discuss O2.
Bro, that's oxygen, bro. Look. O2. One.
element. No, it's actually 5 of them.
No, it's not.
Yes, it is. Yeah,
O2. Oh my god.
it's a secret tree inside. It's actually because oxygen is one
All because oxygen.
So there's actually
Is a part of
Alright.
it's actually 9.
Let's go with Ashley on this one. Ashley, is O2 an element, compound, or a mixture? Okay, why would it be an element? Be quiet, hold on. We need to listen. Yep, it's only one type of atom. You're right. And it's a what? Pure substance. We make mistakes sometimes. It's okay. We learn. Alright, here we go. Let's switch it up. Y'all remember these?
Yes.
Y'all discuss A.
A is a compound.
Discuss A.
A is a compound.
It's a mixture, bro.
Oh yeah, no. No, I got no. I know. A is a mixture. B is a compound. I got
They have more than her.
Because it's my least favorite color.
Alright, here we go. A. Why would it be a mixture?
Because the atoms are not like chemically bonded and like they're separated.
Exactly. Good job. Good job.
Good job.
Alright, let's do B. Let's talk about B very quickly. Did y'all talk about B as well?
Yes.
Alright, B. Let's do somebody that ain't answered yet. Tolliver. B.
B is a compound.
Okay, why would you say compound? They chemically combine and we have two or more, right? Alright, good job. Let's look at the next one. We're gonna talk about C and D next. Go ahead.
Oh, wait. It's an element. Girl.
I keep getting mixed up.
B is an element. C is a, what is it?
Line.
You can have one blue, and then you can have one black, and you can have that's all you get though. You can't.
Y'all know what reverse black.
Stop. Okay.
Alright, let's talk about it. C. Let's do Jocelyn. True. Okay, why would you say C was a compound?
Because it's more elements that are chemically bonded.
Alright, do we all agree? Yes. Ari, the next one.
D is an element because all of the particles and molecules are all the same. They're the same color, the same shape.
Alright, you said D is a molecule? Good job, good job. And if you don't see molecule, what else would you choose? Element. Alright. E and F. Here we go. E and F.
You gotta be a mixture.
It is a mixture. Because I know I'm just
F is the comp. No, F is the element.
yes.
Y'all agree? Y'all agree?
Yes.
Y'all agree?
Yes.
Agree?
No. I said no.
Alright, here we go. Emma. Letter E. Perfect for her. First, you gotta decide what's the element compound or mixture. Then we get to part 2 of this question. A mixture, okay. And it's a mixture of what?
Two or more substances.
For our substances, which is what? A mixture of.
Two or more substances that are not bonded chemically.
So what is that word?
Mixture.
Right. We know it's a mixture, but a mixture of what? What class? Compound. Compound. Mixture of compound. You told me it was 2 or more elements chemically combined. Yes, but this is a mixture of compounds. Okay? Mixture of compounds. And the last one should be easy. Easy peasy. F. Aiden.
mixture. I'm compound.
Compound. Remember glucose. Alright, and the last one is aluminum. Element. Alright, now, quickly, with your group, I want you to represent an element, compound, and a mixture.
Okay, an element, we got those two. A compound, we got these two. And a mixture, we got all three groups.
Y'all should have enough to represent an element, compound, and a mixture.
Wait, no, you didn't show me. So now this is a mixture. This is a mixture. Yes, it is. Because that's a compound. That's an element. So when they're all together, that's a mixture. That's grass. That's grass. Okay.
That's a mixture.
That's a grass.
It's a mixture.
Grass is
What? Mixture of compounds.
Element, compound, and your mixture.
I think that's
Element, compound,
compound.
element,
You don't know cars? What? Don't know Disney.
element,
Yes. Nah, mayor. Mayor.
alright, and last one, element,
Element, compound, and mixture.
mixture. Okay. Good job. Alright, last thing for the day is our execution. Up. We're on 0. We're on just 0. Y'all can give me a scratch sheet of paper that is starts with 5. Execute for the day, we're on 0. One person, y'all can take those magnetic circles in the middle of your table for me. Yeah. Quickly.